All right, so I do want to explain a couple different things here. Yesterday we were doing notes. I had done some PowerPoint slides with you guys, and on those PowerPoint slides, if you weren't here yesterday, so I took all the PowerPoint slides, I turned them into a PDF, I posted them along with, I posted them up on Canvas. So if you weren't here yesterday, you can get these slides that we did in class yesterday from that, from Canvas. Now, I am going to ask that you actually turn in the notes that we did yesterday as an assignment. Now, I'm not making it due today. All right, I'm going to change the due date. I don't even know what I set for. I just threw it up there and posted it yesterday, but I'll make it set for like tomorrow, so that you have time to get that posted. Anything that you took for notes, just take a picture of it, submit it, and you'll get credit for doing the notes for yesterday. But again, we did do some review on a couple of different ideas before we got into chapter 7. Then we started talking a little bit about similarity transformation, which the only similarity transformation that we're dealing with is a dilation. And again, a dilation is going to be some type of enlargement or reduction. So it's this, that's what this whole chapter is really based on. We just barely started hitting on the idea of doing it on a coordinate plane. And that's where I'm going to stop using our green book from 7.1. And I passed out a paper from my old red book that says 7.6 on it. It's still the same material as what's in 7.1 in our green book. I'm just using it to, again, fill in gaps because like I've done before, I don't really say like our green book too much for some of this stuff. It goes into some very confusing details that I don't think are necessary. So I'm going to use that worksheet instead for the next part of this. I'm also, let me show my Canvas page for a second. So on Canvas, like I said, I posted, I just want to show it to you on there. When you click on the assignment, the PDF that's attached to this assignment, that is the notes that we did yesterday. So anytime I post notes there, I'll add them as a PDF. I'll also start trying, since I'm going to be posting a little bit more on Canvas like this, I'll try attaching videos sometimes to this. So I'll record some of the lessons. It's not necessarily going to be during this class period all the time, but during one of my class periods, I'll try to record any of the notes that I do so I can post them on there with the assignments, so that if you miss something, I know right now, I don't know if you guys got the phone calls the last 2 days about like COVID cases and stuff, but there's a lot of them. So I know that it's hard to make stuff up when being quarantined. So until those go down, I'll try making a point of posting more videos and stuff so that you guys can get caught up. But on here, that assignment is from yesterday. Again, I'll make sure I extend the due date out probably until at least tomorrow, so that you have plenty of time to upload. The page that you got today, that is the assignment that is going to be for tonight's work. I'll use some of the examples on there so that we have some practice first, and then I'll let you guys start working on it. So, yeah. Yes. All right. And you notice I am using Zoom to record it because Zoom records stuff in a very small file format for me. So that's much easier for me to post things to Canvas. It's smaller than posting things through YouTube or recording things via the document camera software or anything else. So just give me a second because I have not. So on here, and my document camera still jumps around, so you just have to deal with that. There we go. All right, on the front side, so there are some notes that go along with this. Some of the things that we talked about yesterday: dilation, scale factor, enlargement, reduction. Those are all there. Now, different books use different things for a scale factor. A scale factor is a ratio, which I'm going to go over ratios a little bit more tomorrow, just to refresh our memory as to what a ratio is. But a scale factor is a ratio, and it's the ratio between the two images of our dilation. And it's comparing the length of our final image to our pre-image. So when we have an enlargement, our scale factor is going to be a number that's greater than 1. Or if we have a reduction, it's going to be a number that's less than 1. Now, to be more specific, it's between 0 and 1. So determine whether the dilation from A to B is an enlargement or a reduction, then find the scale factor of the dilation. So looking at this figure, they said that B is larger than A, so the dilation is an enlargement. All right. Well, so they're saying that A is the pre-image, B is the image. So since B is bigger and A is smaller, we would have to have an enlargement here. Well, how do we actually figure out what the scale factor is? Well, we need to look at one of the lengths of our sides. Good morning. So on this one, if we just count the length of any of the horizontal or vertical lines, then we can figure this out. So we got this length here is 2. This length here is 4. So since we have a length of 2 and a length of 4, we're going to compare those in a scale factor. Since this is the image and this is the pre-image, it's always going to be the image length over the pre-image length. So down here, you notice they put 4, since that's our image, and 2 on the bottom, since that's our pre-image. So again, this is our image, this is our pre-image, and 4 over 2 reduces to 2. So our scale factor here is 2. And again, we already said that it got bigger, so it's an enlargement. And this number is greater than 1, which tells us, again, it is an enlargement. So we did that correctly. If we go over here to the second example, now they're saying that the bigger figure here, A, is our pre-image, whereas B is our image. Now, we have a couple of slanted lines here. We don't really want to use those because if we use those, we'd have to actually find a distance or length for those. So that's a little bit extra work. We still have this vertical line over here that we can use. And for our image, this length is 3 spaces. For the image, it's 3 spaces. So on top, we can put a 3. On bottom, our pre-image, which is the bigger figure, 1, 2, 3, 4, 5, 6. This is a length of 6 units. So it's 3 over 6, which we can reduce down to 1/2. Again, 1/2 does fall between 0 and 1. So that is a reduction. All right. And again, if you look at what they wrote there, they wrote the same thing. Again, from A to B, it got smaller. It's a reduction. If we compare the lengths of the sides, we had 3 was the length of the one side of our image. 6 was the length of our pre-image. So we got 1/2. Again, for a reduction, our scale factor falls between 0 and 1. Now, actually, let's go to this other side here. So essentially, everything here is kind of the same. But the figure that I want to take a look at before we do anything else is part B here. All right. On B, all right, here we have an image where we don't have any horizontal or vertical lines. All right. There's no horizontal or vertical lines here. So on this one, we have all of these diagonals. Well, in order to find a length, in order to say that this is actually, or what the scale factor actually is here, we'd have to compare these lengths. Well, in order to do that, you actually have to use your distance formula, or you could look at it as Pythagorean theorem. So down here, they found the length of each of the pieces on here. You don't have to find every single piece if we're just trying to find a scale factor. And I am going to change some of the directions on the other side because, like I said, I'm combining ideas from one book and another book. So this is already getting into one of the other things that we'll talk about later in the chapter. But just for identifying scale factor here, if I want to find the length of this piece, I'd have to actually plug into either Pythagorean theorem or distance formula, solve for that one piece, and then compare it to the other one. So down here, they already did all the work for us. They said that this piece was 2 and this piece was 5. But again, you're going to have to use your distance formula or Pythagorean theorem. So if you don't remember it from first semester, I'm going to write it down so that you have a reference. If you want to do it as distance formula, it's going to be the square root of x2 minus x1 squared plus y2 minus y1 squared. All right. That's our distance formula. If you want to look at it as Pythagorean theorem and figure out the length of the side just by looking at the graph, that's fine. For Pythagorean theorem, remember that is c squared equals a squared plus b squared. Again, they are essentially the same formula because the difference in your x values is essentially a, the difference in your y values is essentially b. And then you'd have to get rid of the square root, so you just end up squaring that side. So the work that they show down here looks a little bit more like Pythagorean theorem almost, because again, those are the same thing. Again, those are 2 equations from the first half of the year that we're going to be using again. Now, so keep those in mind. I want to take a look at some of the exercises down here on page 37. So go to the bottom of 37 for me. So on here, they want us to find whether or not these are reductions or enlargements. So first off, just going through them, let's say whether or not it's a reduction or enlargement. On number 1, so we had figure A, then we had figure B. So this is our image. This is our pre-image. Did it get bigger or did it get smaller? So from A to B, it got bigger. All right, it got bigger. From A to B, it got bigger. So that means it's an enlargement, right? Man, my nose just won't stop running here. Give me 1 second. All right. Sorry. Yes. Yeah, go ahead. Passes right here. All right, so that's an enlargement. Now, on the second one, we have A to B. A is this one, B is this one. Did it get bigger or smaller? Smaller. So since it got smaller, it's a reduction. So before we even find the scale factor, we can clearly tell whether or not the image is getting bigger or smaller by itself, right? So we should be able to say what it is. When we go to find our scale factor, we should make sure that it fits what's happening. So since this one we said was an enlargement, our number here should be greater than 1. For this one, since it's a reduction, it should fall between 0 and 1. If you do the scale factor and you don't get the proper number there, then maybe you did it backwards. Go back and check your work. All right. So on this one, we have the length of this bottom segment, which is the only horizontal line in there, is how long? 6 units. The bottom edge of this one is how many units? 3. So what's my fraction going to be when I write that scale factor? All right, so it's going to be 6 over 3. Again, if you wrote 3 over 6 and try to reduce that, you get 1/2. Would that make sense? No. So then again, it's always our image over the pre-image. So 6 divided by 3 is 2. And that is a number greater than 1. So that is an enlargement. So again, you can always check those numbers because when you put them over top of each other, you're going to either get a number that is greater than 1 or a number that's less than 1. All right. I will tell you, every year on the tests for this section, I always get answers that make absolutely no sense. I'll have people say, all right, it's an enlargement and the scale factor is 1/3. Does that make any sense? Again, if you can clearly see that you have an enlargement, you know that it's getting bigger. The number has to be greater than 1. On this one, a reduction. All right, so count the spaces and tell me the length of that top edge here. All right. Again, it looks like that top edge is 6. On this one, the top edge is 3. Which one goes on top this time? It's a 3/6. So this one becomes 1/2. Again, it's reduction. It got smaller. All right, go over here to number 3. All right. Now, we can still clearly tell that it's getting smaller. So this is definitely a reduction. Doesn't look like it was reduced by quite as much, though. So let's go with this side. All right. On this side, we have how many units? 4. And on the same side up here, we have 5. All right, which one's going on top? 4 or the 5? The 4. Again, image over pre-image. That value is less than 1, which makes sense for a reduction. 4 is now the challenging one. Are there any horizontal lines here? No. So if we're comparing the sides, we would have to do a distance formula. All right. So on here, let's say we do this one. Again, we can do distance or we can do Pythagorean theorem. I almost always go with Pythagorean theorem just because I like doing that one. Here we have a length of 2. Here we have a length of 1, 2, 3, 4. So we're comparing the length of the sides. I first need to find the length of that piece, which is going to be found by doing c squared equals 2 squared plus 4 squared. 2 squared is 4 squared is. Add those two up, you get. And then we got to get rid of that square, so square root it. Get square root of 20. On this other one, we have 1 space over, 2 spaces down. You're going to do the same thing. 1 squared plus 2 squared. 1 squared is 1. 2 squared is 4. 1 plus 4 is, take the square root of it to get it by itself. Now, we need to compare these. So this was our image. This was our pre-image. So we're doing the square root of 5 over the square root of 20. Now, I did not simplify these radicals yet for a reason. Those numbers can be reduced because 5 goes into 20, right? How many times does 5 go into 20? 4. So I can reduce this fraction by dividing both the top and bottom by 5. So I get 1/4. Now, square root of 1 is just 1. Square root of 4 is, and again, we didn't have to deal with simplifying a radical. Just save it till the end. Sometimes we can get away without having to simplify. All right, so that's 1/2. Now, that one's a more challenging one, but we got this scale factor of 1/2. Was this a reduction or enlargement? It's a reduction, right? And let's double check it with our figure. Did it get smaller? It went from A to B. Yes, it did. All right. So again, you could find your scale factor first, or you could say the reduction and enlargement part first. And for the most part, as long as you have a horizontal or vertical line somewhere in the figure, there's not a whole lot of work to be done. It's when everything is a diagonal that requires a little bit extra work. All right, let's go over to the back. Now, I'm not having you do the entire back. what I want to focus on is just the parts that are determining whether or not it's an enlargement or a reduction, and what's our scale factor. So this top part of 1 through 4, that's homework. You do not have to do the bottom half of 7 through 8. And then on the other side, I want you to do 1 through 6 as part of your homework. You do not have to do 7 and 8. I'm not gonna make you do 9 either. So just those top 2 sections of 1 through 4 and 1 through 6. That's your homework assignment. All right. And you still have time in here. Again, I still am so confused with this new schedule. Look at my 38. Is that what you said? I'll trust you on that one. So we still have 20 minutes. So you could get this done in class. I'm going to post this assignment right now. Again, it'll be due by 5 minutes into class time tomorrow. And I'll also post the little recording that I did along with it. Now, a lot of times I'll post the assignment first. And if I do a recording during one of my classes, I might end up posting that later because it does sometimes take a little bit of time for the recording to process. So stop that.